Gonna start with a quick and easy little project here. Hi Bandit, how are you? Anyway, cut out the template already. Left side, let's see. There she is. So, got some diamond plate back there. You can see it won't match identical to like the originals, but it's diamond plate nonetheless, and it should look good. The running board support bracket from there looks like it's not in too bad a shape, but under here, this is what I'm looking at. Right here, she's not horrible, but it's 8 through here. It's actually 8 through there. It's eaten through here. It is completely gone here, and it apparently fastens inside of this bracket, which for the most part, and this is a body bracket as well. That's a body mount right there, and it is shot. It is just absolutely shot. Now some kind of rust proofing that went on in here. Didn't really do its job. Yeah, that's a rust proof type stuff. So be knocking these rivets out and bringing this off, recreating this to support the running boards. Yeah, for a vehicle that was undercoated, pretty crappy undercoating. But anyway, that's what she looks like right there. We'll be addressing that. We'll take a look at the other side.
This image on Amazon was the only reference I could find as to what the running board support would look like when completed. And this was the underside of the running board itself.
And the great part about symmetrical parts is that all I have to do is flip it over and I have my right side. So I have a 7-inch piece of diamond plate, leftover scrap from another project. I'll utilize the straight edge along this one side, and then I'll just mark it out, and I'll just have this, and we can put the plasma cutter to it and not even burn much material here. So we'll just kind of, and then we can clean up the edges later. There you have it. Now what I'll do is I'll flip it over. So let's see. There's the left side. So I want a right side. I was thinking, yeah, I can still do this. I will utilize this as much as I can. A straight edge here. And we'll just knock that out. Now that I have my running boards marked out, what I have to do with the plasma cutter when I use this, right in the center is where, right in there is where the plasma flame will come out. And so this edge is kind of a guiding edge right here. It's usually about 3/16 of an inch, gets me pretty close to where I want to be. So when I set up my straight edge on here, I'm going to set it off about 3/16 of an inch so that my cut line is right on my line here. And then by the time I weld the outer edge on, which is about this thickness, maybe 12, 14 gauge maybe or something, maybe 12 gauge, then I'm going to have a good stiff running board, and that'll make up the distance so that I should be pretty much exactly where I need to be. So I'm just going to cut it off right here so I don't have the whole 8-foot length of metal to work around, and then we'll have our parts cut out. This is a perfect example of how plans change. I actually had already cut these out of diamond plate aluminum, polished up, and of course I would need to repolish it when I got done, but I decided that the direction I want to go with this build on the Toyota Landcruiser was going to be different, more rustic, and so that's why I'm switching to the diamond plate steel, and I just think in the long run it's going to work out better for the direction I want to go with this build. And these, you know, if I build another one someday, they're going in the stockpile. And if I build another one someday, maybe we'll use them for that. Well, now that the cutting's done, this is a piece that is going to go, of course, here's the running board, and this is going to get welded around the outside edge. Because the metal brake that I have, plus we've got these radius ends here, the metal brake that I have will not handle this, this thick of steel. This is probably, I want to say 14 gauge. This is probably 12 gauge. And so what we're doing, we're at the, what I call the static roll. And it's 3 pipes welded together. This is a 2.5 inch, so 1.75 inch onto a 6 inch. Typically would have liked to had a 3 inch over here for that just a little bit bigger radius, but I had some 2.5 laying around. There you go. So we get that. It still does a nice job. I just don't close it. Same thing here. So there's a gap in between the pipes here where I can fit this in, and I can begin to make my radius for this back edge of the running board. And truthfully, right here is about my best option, the 1.75 inch, and I just won't close it all the way, and then I can manipulate it a little bit to work out. So I want to get it up just a little bit, and if I do this right, I see I'm going to have to, and then I'll adjust that a little bit. I won't do it all in one spot. I'll move it up a little bit and expand that bend so that it's more of a bend like that. And then that's got to fit onto there, and holy smokes, I've got that about perfect. I don't know if you can see that, but that baby's about perfect right there. And then I'll just trim the edge. I'm going to bend this over just a little bit more. I need just a little more. So I'm going to come down here. Get that. Now again, I knocked all the slag off because I don't want to scar up my anvil pipes here. And which, by the way, a lot of guys refer to this as a pipe anvil. And again, the idea came from Gene Winfield at the SEMA event, where he drew it out on a board, and not only myself but several other guys took advantage of that and have fabricated themselves either what I call a static roll, because everything you do to roll metal over it is done by you, nothing on this moves. Or it's called a pipe anvil. Some guys prefer that. But either way, invaluable tool for manipulating metal, getting bends in things, and without a lot of struggle to it. So, great tool. It appears that the static roll, or the pipe anvil, was the cat's meow. You can see the flange metal has formed up real nice with the running boards. And of course, the running board will be welded to the top of the flange metal here so that the flange actually works its way down. But anyway, and then there'll be one more straight piece. I've got a couple of those under here that will be welded in on the back, and it basically boxes in the running board to make it nice and strong. Okay, time to tack it together. First one is done. Got it tacked on various spots on the inside, and then we'll TIG weld the outside of it together, and that should buff off real nice. Anyway, makes a nice solid running board. And we're going to do the second one right now. And I've got 18 gauge, 20 gauge sheet steel here, just as little shims to hold the flange metal off the table so that I get a little bit of a pocket there, and I can fill that in with my weld on the other side. It's not going to be much of a pocket, but it does make a little bit of a difference. So, and boy, I'll tell you, I come right to the edge there with that. So we're in pretty good shape. I'm going to go ahead and just tack it together, and we'll see how she goes. Let's see. Going to do short little maybe 1/2 inch runs and stagger them so as not to create too much heat in any one area and create a warp. They welded up pretty good. I don't know if you can make it out. Doesn't have to be real pretty under here, but it's in there, and it's going to make them real solid. Now, like I say, on the top side, we'll do the TIG, closing up that seam, and by the time we buff that down, it'll look real nice on the outside, be real strong on the inside. And can't get any better than that. There you have it. We got the 2 running boards made, one upside down obviously, so you can kind of see how everything went together. The other one is right side up. This is how it'll fit on the right side of the vehicle. And this edge up, down all along in here is going to get TIG welded. Of course over here too, all around. And TIG welding is a softer weld, and it should sand off of the flap wheel real nicely, and we'll end up with a nice finish here. So anyway, tomorrow, TIGging. This is a template, and it's going to be made out of aluminum. Looks like maybe 125 thousandths aluminum, and going to be used for the support bracket for the running boards, and I have to make 4 of these. And put some soap on the blade, keep it from loading up with the aluminum. Now, like I said, I have to make 4 parts out of basically the same thickness, 1/8 inch basically, of steel for the support brackets for the running boards. This is going to be a template that I can go around with the plasma cutter, and by the time I adding that 3/16 of an inch all the way around, this is cut 3/16 all the way around shy. So when I go around it with the plasma cutter, I should be at the right size that I need for the brackets, and they'll be close to being a finished product then. But that's my thing, a little bit of filing to smooth the edges off so it's not hanging up the plasma cutter, and we'll be off to the races. All right, these 2 panels that I just cut out over on the stomp shear, these are going to be for a bracket that, as we've made our running boards, there's a back bracket that runs down through here, about 17 inches worth, and this is its profile. I don't know if you can see that or not, but that's its profile. And in doing a test piece like this to figure out which is the best way to approach the brake in bending this thing, and then ultimately I'll have to probably do a little bit of hammer forming to shape it because I have to unbend a little bit to get the final bend into it. I realized, of course, that I couldn't go 1 inch, 1 inch, 1 inch, and when I have a 3/4 inch flange on this. So in doing that, I realized my down step here needs to be only 3/4 of an inch, and I'll correct that. And I had to make up new mounting brackets for the run board, and these are made out of 1/8 inch steel. And ultimately then there's a bolt that goes, once this gets bent up, it's in here, there's a hole drilled, the bolt welded in so that it can bolt up from underneath. Hole will get drilled here, and then of course it mounts to the body mount back there, right off the frame. So that's what I'm working on right now, get this finished up, and then the running boards will be done. So I don't know if you can see it. Look in here. Anyway, it's marked out. Got 4 lines on either side, which will make 5 sections. And it's marked out on both sides because at some point in the metal brake, it's gonna have to get flipped, and I gotta be able to know where those lines are. So both of them are marked out. I'll head over to the metal brake, knock it out. All right, I gotta duck down so you can see me here a little bit. I wanted you to be able to see the metal. Now I ran a test piece through here, and I'll be darned if I can remember exactly how I did it so that I get my bends just right, but I think we'll be okay, and we'll just give this a go. It's 18 gauge steel. It'll be no problem for this bender, and we'll see what we can get done. I had to move the camera. It was in the way of the bending table. So we'll give it a go here. Take it about a 90. Then take this in here. Oh yeah. right about there. Then I'm gonna bring this one more time. See if I did this right. Yeah, this is where we run into a little trouble here because we're tight. I may have, because that's not going to bend. It's 18 gauge, fairly tough. I may not get that to do that. I might have to do this a different way on this last bend. We'll have to see. Anyway. Okay, so here's the plan. I use this 1-inch metal bar, which is a little bit bigger than the flange that I want to make here because my step here is only 3/4 of an inch. So I had to make marks on the table back here to know where my actual bracket fell in relation to the edge of the table. So what I'm going to do is I'm going to use the edge of the table as a metal brake, and we'll just knock this down, get a good start on it, and then we can finish it off with a hammer and dolly, and it should be like new money. So we'll get started on that. I'm not going to try to bend it all in one big whack. I don't want to stretch the metal out of shape too bad. So I'm just going to work my way across, knocking her down little by little. I got a square hammer here so I can get into the right up next to it. Where there's a will, there's a way. I'm actually driving my hammer down as I hit this to keep it close to the table. See what we ended up with here. It's important to sandwich that metal so that it doesn't move on you when you're bending it. So, see how we did here. Pretty close, little hammy, little hammer and dolly work, and I think we're going to be there. That'll be okay. So we'll do the other one quick, then we can finish them off. And it just occurred to me, what I could have done with this was go over to the bead roller, and I could have tipped a wedge right in there and had that nice and snug. But we'll get her. Okay, pretty pleased with that. They came out pretty good. A little more work there. Get them to fit up snug and then clamp them in place, and we're off to the races. But it will actually, they fit in there just actually about like that. That's how it will look. And there'll be a hole drilled right about here, 5 inches back, 2.5 inches in. And that's where one of these will actually fit up into there. So
those babies are about done.